Hi everyone, I'm Madeline. For my section, y'all know me, but for the 1411 sections, I am the prep TA this semester for 1311 and 1411. So I know y'all sections didn't really work all that great, so I wanted to record this video both for my section since I was sick, as well as y'all since it didn't work for y'all, and that was completely on me. I was rushing to make the solution Wednesday night, did my calculations wrong. So that tells you that your calculations are very important, even in the laboratory. So to get started, I'm just going to do my pre-lab lecture like I would if I were teaching in class right now. So Lab 4 is supposed to get you used to volumetric glassware, making standard calibration curves, as well as the ultraviolet visible light spectrometers. So first I'm going to start off with kind of the background information for the UV vis that we're going to use. So this is a fairly simple, just plug and play one. But for a UV vis, you always have a light source. So that light source is going to produce light of whatever wavelength. Then we have a cuvette that has whatever our sample is. That light is going to pass through our cuvette to a detector. So this is our cuvette. This is our light source. So it's really that simple. The light passes straight through your sample, and that's how we are going to get this information. So why are we even getting information out of that? How are we getting information out of that? So as you should see in this lab, our sample is actually going to have a color to it. It should be a really nice blue color. So that is, of course, in the visible spectrum. So this spectrometer in particular is a UV vis. So ultraviolet. So ultraviolet like sun rays. And visible, like what our eyes can see, visible light. So we're going to get our information in this range. So since our compound has a bluish color, that means we can get some kind of information in this range. So when the light passes through, it's going to do one of three things. It's either going to absorb onto the particles of the solution. Those particles are going to scatter the light, or it's going to do nothing to them, and they're going to pass it straight through. So that means they're going to pass to the detector. So for this spectrometer, we're going to kind of gloss over light scattering. There are other instruments that specifically rely on light scattering, but we're going to focus on absorbance as well as transmittance. So for absorbance, that means what reaches the detector and what is given out is based on what does not reach the detector. Whereas, I'm actually going to rewrite this as transmittance. Or just transmit, because light is transmitting through. That means what we're getting that actually passes all the way to the detector. So the values that you would want to get for this lab are in absorbance. That's how we're going to base our equations. You could use transmittance, but we're going to stick with absorbance. So for the procedure today, actually get my boards. Get all the boards. So, for the procedure for this lab, it's very straightforward. We're going to weigh out about 0.315 grams of our copper sulfate pentahydrate. So, we want to record that exact mass. We're going to put this into a 50 milliliter volumetric flask so that we have an exact concentration of that in solution. Then we're going to take that 50 milliliter volumetric flask of our very specific concentration of copper sulfate, and we're going to create 5 solutions based on this chart here. So it's kind of cutting off in the video right now. There we go. So basically we're just decreasing the amount of our copper sulfate that we're adding. So that should show us the difference when we take absorbance of it. So all of these numbers are based on a 50 milliliter volumetric flask. The procedure says we would use a 100. We pretty much just made that decision because we did not have enough material for y'all to actually make 100 milliliters full of solution. So I'm going to do the lab exactly how the rest of the sections this semester did it, and how the 1411 attempted to do theirs. So we're going to make those solutions based on our chart, and then we're going to fill our cuvettes about 3/4 full with each solution. So the thing about a cuvette, I actually have one right here. So if you can kind of tell, there's kind of a hazy side to it, and there's a very clear side to it. So you want to make sure the light is going to pass through this clear side and not the hazy side. That's going to mess up your values. So the other thing about these cuvettes is you always want to wipe them down with a chem wipe while you have gloves on, because you don't want to get the natural oils from your hands onto this. That can also mess up your values. So when I put those into the UV vis, I will wipe these off, and of course I'll have gloves on. So after we record all of our peaks, we want the highest peak because that's where it's going to have the highest absorbance. You can kind of play around with that on the software. I will play around with it in this video so that my section can actually see that, but hopefully the 1411 sections, you did play around with where the cursor was, what wavelengths for what. But we're going to take the absorbance at the highest peak. So after we get all of those, that's how you're going to build your calibration curve. So you can basically just plot each one of those, 1, 2, 3, 4. Well, based on your concentration of copper, because that's the correlation that we want. We want absorbance versus our concentration of copper. So that's why we also have this section here that's blank. You would fill this in, and we'll put in the data, or at least you'll have the data to be able to fill this in. And then once you have your calibration curve, well, what use is a calibration curve if you're not going to actually test solutions or samples against it? So originally I had considered making sodium chloride and copper sulfate unknowns that each group could see what their concentration was based on how much of that copper sulfate I had put into the sodium chloride solution, because the sodium chloride really shouldn't change too much in either the absorbance or in the chemistry of how the rest of the reaction happens. But instead, since I got sick and I actually didn't get to make those beforehand, we're just going to choose a different concentration. It's written up here on this board. So we're going to pick a number somewhere between 0.1, 0.25. I'm pretty much just going to weigh it and see what I get out on the balance. Write that down, use that as my unknown concentration, We could, of course, calculate it based on this way, but you can at least see that if you have an unknown and you know what your solute is, then you can use this method to see what your concentration is without having to do a whole ton of other extra math. There is, of course, still math involved. So then we're just going to do same procedure as we made for the rest of our solutions. We're just going to do it with a unknown amount of salt. And then for every single one of these, we're actually going to do these in triplicate. So that means we're going to take 3 measurements for every single solution. Now the reason we would take triplicate is because at least 3, you can take an average, and you also have a standard deviation. So those are actually statistically relevant. If you have 2, you can at least get an average, but you can't really get a accurate or we'll stick with accurate. You can't really get an accurate standard deviation from that. So having at least 3, 5 is preferable in a lot of disciplines, but at least 3 is going to give you a much better idea of where your average is, what your standard deviation is. So just for y'all to practice, it's very easy. Just pop it into Excel. We're going to have that as well. So let me actually get my lab coat and goggles on, and I will switch to my phone recording so that I can show y'all how to go through the lab, and then I will, of course, post the data.
Okay, so now you can see that I have my setup here. Of course, since I am doing this by myself in the lab, I'm going to use all of the caps and volumetric flasks that I need. I have my tape, I have my Sharpie. I went ahead and got my pipettes out. I have my graduated cylinder to measure out volumes, DI water. I have my solutions, and I have my copper sulfate pentahydrate. So let's go ahead and weigh out some of this. I would pick the balance that does not have any weigh paper. I see some. Let's grab some. So normally I would have 2 hands, but if you have never used weigh paper, the best way to use it is to fold it twice, preferably in straight lines, diagonally. And that makes you a nice little boat. So now let's plop that onto our balance. Let's turn our balance on. Let me get a scoop. That should be clean enough. And let's weigh out. Well, let's tear. And let's weigh out about 0.3 grams. That's 0.36. Don't know if my paper was quite teared when I put that on there. So let's do it again. It's thinking about it. Sometimes it helps if you close everything. There it goes. Okay. So now that's zeroed. Okay. I'm just going to use what I had before I put it in the lid. So that is pretty good. Let's let it settle. Actually step away from it a little bit. I think we can call it 0.3171. I know it went up right there at the end, but we will call it that. So I'm going to take this over here, back to the bench. Ideally, you would want to have a notebook, and I intended to have an Excel sheet written already, but we are going to write this on the board. So 0.3171 grams copper sulfate pendihydrate. Okay, so I made note of that. Now, let's go ahead and say we are going to put it into this one. I am going to actually get a funnel, which I did not consider getting. These volumetric flasks are very tiny. Oh, there's a funnel. It's not the cleanest, but I think it'll, I don't want to use that one. It's got some grime on it. That looks a little bit better. Okay, so we're going to use a funnel. This looks relatively dry. If not, we will use some DI water to rinse it out. Okay, so we should have all of our copper sulfate in there. It looks like I do have just a tiny bit stuck in the funnel. So I'm just gonna wash that off with some DI water. And now it should be good. Just put my funnel over here. I don't need my way paper now. And now I can actually bring that funnel back. That is going to make pouring this DI water so much easier. Okay, I had to put the phone down to actually get my bottle. So we're just going to let it pour some water in there. I don't want to put very much at a time because we do want to hit that mark right on it. And that is extremely close. So now, since my bottle is open, I'm actually going to use a pipette and just put it dropwise now. That is looking close. Let's check. So that could use probably a couple more drops. 1, 2, let's see. Yeah, so I think that is fine. So this is my DI pipette. I'm going to put it over here. So now I'm going to close this up and I'm going to invert it. We want this copper sulfate to actually get dissolved. You can give it a couple shakes too. You basically want all of your little salty bits, so you can still see some solid in there, to get completely dissolved. Because if you do not, then your calculations later will be off because the solution that you're using won't actually have the full amount that you measured out into it. That one piece is being really stubborn. Let's see if I can get it. So I'm just shaking it a little bit. That one piece is pretty stubborn. I don't see it. So now I think it went into solution. So we should be good to go with the next part. So I am going to label all of my flasks, which requires me to put my phone down. I will be right back. Okay, so now I have all of my flasks labeled as well as all of my pipettes. I just went ahead and put these over to the side so that we can use them when we actually fill our cuvettes, because we don't want to contaminate them before that. So I also have one labeled for my copper solution itself. So now let's see what we should measure out for each thing. So for the very first solution, let's just go ahead and measure out all of our copper solutions. So I have a graduated cylinder. So we want to do a 15. So you can use this plastic piece just to kind of make sure that you're not going too far. So since this one is a pretty good bit, but I can't get the stopper off with one hand. Give me 1 second. Okay, so now that I have the stopper off, I'm going to go ahead and pour some in here. So you can see that I kind of went over. So I'm going to use my pipette. If I can get it down in there. To slurp a little bit up. And now that is pretty close to 15. That's pretty close to 15. So now let's see how close to 15 this is. I'm actually gonna undo this a little bit and read my meniscus. My meniscus is a little bit under 15 actually. So I'm going to record this as, I think I'm going to record this as 14.25. So on the board, I'm going to write that. So I actually put in 14.25 milliliters. So I'm going to add that to flask 1. Probably want to use our funnel again. Okay, so that's solution 1. Let's prepare solution 2. So now we want 10 milliliters. So I'm going to scoot this plastic piece back up. Actually, I think I would just use it as some contrast. I'm going to go ahead and squeeze this out. And then actually pour. Yeah. So definitely, let's see, am I under 10 or over? I'm under. Okay. So now I'm going to use my pipette, draw some up, and very carefully add some more. Okay. So once again, checking my meniscus. That's still under 10, so I'm going to bring it up just a little bit. think maybe one more drop. Maybe a couple more drops. There we go. So yeah, I would call that one maybe 9.8. So let's write that on the board. So we have 9.8. Really, we can't really guesstimate this one. We want a singular decimal point. So, into the second one it goes. So there is 2. Let's do 3. So at this point, I want to make a note that, just like my copper one, from this point, using this volumetric flask, or graduated cylinder, I'm sorry, that I've been using, these measurements are going to be not as accurate as what we have on the board. So at that point, you would have 2 options. You could either get a different volumetric, I keep calling it a volumetric. You could get a different graduated cylinder that is a 10 milliliter so that you can actually tell closer to 7.5 and 2.5. Or you could use a micropipette. We haven't gotten those out this semester, so I'm not going to get it out in this one. So I think I'm just going to stick with this graduated cylinder, but keep in mind that our concentration is not going to be exactly spot on like we would want it to be, but we are just going to kind of roll with it. So we want 7.5 for this one. I actually think I am going to raise this up some so that I can at least get that. That's right around 7, and so I can fill it up there and then increase from there. So this is actually how I'm getting my solution right now, because I don't want to try to pour it with this small of a volume. I say that, and then I think I will just pour some. So let's see where that got us. And that is, actually, yeah, I think that is about as close to 7.5 as we could get. So obviously the little yellow thing is a little bit farther down, but this larger line is 5, and so 1, 2. Our meniscus is about 0.5. So we're going to say that one is 7.5 on the dot. We can't really estimate it any closer than that. So we have that. To add my funnel. Plop that in. Try to get all of it on there. That's 3. And if you notice a problem with this graduated cylinder now, it actually doesn't even have markings where you could try to measure 1 or 2 milliliters. It starts at 3. So we're not going to try that. I am going to get the 10 mil for that one. So let's see. Let's find a 10 mil. There's a 10 mil. Okay. So of course, ideally you would have wanted to also use this one on the previous, but we actually got it pretty close. So we're gonna try that with this one too. So that is definitely more than we wanted. But we can use our, no we can't because it doesn't fit. But you really aren't supposed to pour things back into your solution, but as long as you know things are fairly clean, you can. So now let's try to get just a tiny, tiny bit of our solution. We don't need a whole lot. I think we need the longer pipettes. Yeah, because we don't need very much at all. If you had put this in a if I had put this in a beaker, it would have been much easier to get dropwise at this point. Yeah, because I just overshot again. Let me actually get a small beaker so that I can actually measure it dropwise. That is going to make things way better. Okay, so I did a couple of things. I went ahead and moved my label and put my stock solution into this beaker so that I could clean the other volumetric flask so we can use it for our unknown in just a bit. And I also went ahead and got 2 more graduated cylinders so that we can pretty much just go ahead and measure out our ammonia and ammonium chloride without having to wash this one. If we were actually in the lab, you would have to wash your group's graduated cylinder so that you could repeatedly use it. But that's why I just went ahead and did each solution by itself in succession instead of each volumetric flask in succession. So I'm going to put this over here with my cuvette so I know it's dirty. So now let's get 2.5. So that. Okay. So this one might be a little bit harder to tell, especially if my phone does not want to focus. There it goes. Let's put a couple more drops. Okay. So that one went slightly over. I would actually say that one's right on the dot. So for this one, since it's a different graduated cylinder, we can actually put 1 more decimal point. So this one is 2.50. Let's actually write that on the board. Where did my marker go? So this one is 2.50, right on the dot. So now, of course, the last one, we're not going to put anything in there because this is our blank solution. So let's go ahead and pour this into 4 and leave 5 for the next one. Sometimes with these funnels, if they create a seal, they won't actually deposit everything. So you have to kind of take them out, give them a little jiggle. Just be very careful not to break your volumetric flask trying to get everything in there. Okay, let's take our funnel out. Let's put this graduated cylinder over here. So that is all of those. And I'm going to put my copper solution over here. So 5 gets nothing for the moment. We haven't used any of these caps for a specific one yet, so they're not contaminated. So now, for every single one, they get 15 milliliters of ammonium chloride and 15 milliliters of the ammonia. So we can pretty much do that one by one now. I'm not super worried about contamination based on this funnel. I'm not going to wash it in between because it does look like there's... You definitely could wash it. You could just use the squirt bottle DI water into a waste beaker at your station. I actually think I will do that. Let me go grab one of the big beakers so I can do that. Grab a big beaker and DI water that has a little bit more in it that the cap is on. So ideally you would want to actually hold this, but since I have one hand, I'm going to do it like this. Just to make sure it's relatively clean. Okay. There's our waste beaker. And there's our wash. Okay, so we want 15 milliliters of our ammonia. Let's see if we can get that right off. Let's take a look. We definitely need a little bit more. That's why I have a pipette. And there we go. That is just slightly above. But what I'm worried about is the concentration of the copper. So I'm just going to consider that 15. That is not going to affect the copper amount. So I'm just going to make sure that I have 15 milliliters total. So go ahead and chug that in there. So as you can see, almost immediately we put that ammonia in there and the color has changed drastically. Let's make sure we get all of that in there. I don't know. Oh, there we go. That color really went to town there. So that is what color we should have gotten. And that's even before we put the ammonium chloride in there. But we will also put everything as it should. For right now, I'm going to put that one back.